Ever wondered how Netflix knows exactly what show you'll binge next? Or how self-driving cars can tell a pedestrian from a lamppost? The secret lies in the difference between deep learning and machine learning. And today, we're breaking it down. Hello? Today we dive into deep learning and machine learning. In this video, we'll explore the key differences between these two powerful technologies that are shaping the future of artificial intelligence. You might have heard the terms thrown around, but what do they really mean? We'll break down the basics, highlighting how machine learning serves as the foundation for deep learning, and how each plays a unique role in various applications, from self-driving cars to personalized recommendations. By the end of this video, you'll not only understand the distinctions between these two fields, but also appreciate their real-world implications. So, whether you're a tech enthusiast or just curious about AI, stick around as we unravel the complexities of deep learning and machine learning in an engaging and informative way. Machine learning and its advanced subset. Let's explore what sets them apart and why it matters for our future. Machine learning is a subset of artificial intelligence that enables systems to learn from data and improve their performance over time without being explicitly programmed. Its significance in data analysis lies in its ability to uncover patterns and insights from vast amounts of information, making it invaluable in today's data-driven world. There are three main types of machine learning: supervised learning, where models are trained on labeled data; unsupervised learning, which identifies hidden patterns in unlabeled data; and reinforcement learning, where agents learn by interacting with their environment to maximize rewards. Real-world applications of machine learning are everywhere. For instance, recommendation systems on platforms like Netflix and Amazon suggest content based on user preferences, while fraud detection algorithms analyze transaction patterns to identify suspicious activities. Understanding these core principles helps us appreciate the transformative power of machine learning in various industries. Deep learning, where multi-layered neural networks analyze vast data, enabling machines to recognize images, understand speech, and even diagnose diseases without explicit programming. Deep learning is a specialized branch of machine learning that focuses on using neural networks to model complex patterns in large data sets. While machine learning relies on algorithms that can learn from data, deep learning takes it a step further by utilizing multi-layered neural networks that mimic the human brain's structure. This architecture allows deep learning models to automatically extract features and representations from raw data, making them particularly powerful for tasks involving unstructured data. For example, in image recognition, deep learning algorithms can identify objects within photos with remarkable accuracy, while in natural language processing, they enable machines to understand and generate human language. By leveraging vast amounts of data and computational power, deep learning has revolutionized fields such as healthcare, autonomous driving, and virtual assistants, showcasing its potential to tackle some of the most challenging problems in technology today. Machine learning and deep learning may sound similar, but their differences are game-changing. One works with modest data on your laptop, while the other devours massive datasets using specialized hardware to solve our most complex problems. When comparing deep learning and machine learning, one of the main differences lies in the complexity of the algorithms used. Machine learning typically employs simpler algorithms, such as decision trees or linear regression, which are effective for many tasks, but may struggle with more complex data. In contrast, deep learning utilizes intricate neural networks with multiple layers, allowing it to capture more nuanced patterns. Another key difference is the data requirements. Machine learning can perform well with smaller data sets, while deep learning thrives on large volumes of data to train its models effectively. This leads us to computational power. Deep learning demands significantly more computational resources due to its complex architectures and extensive data processing needs. As a result, while machine learning can often run on standard hardware, deep learning usually requires specialized hardware like GPUs to achieve optimal performance. Understanding these differences is crucial for selecting the right approach for specific tasks. From detecting financial fraud to driving cars autonomously, machine learning and deep learning are transforming industries in different ways. Let's explore which technology powers which innovations and why choosing the right approach matters. Machine learning is making significant strides across various industries, with finance and healthcare being prime examples. In finance, algorithms analyze transaction data to detect fraudulent activities and assess credit risk, while in healthcare, predictive models help in diagnosing diseases and personalizing treatment plans. On the other hand, deep learning is revolutionizing fields like autonomous vehicles and robotics. For instance, self-driving cars rely on deep learning to interpret sensor data and make real-time decisions, while robots use it for tasks like object recognition and navigation. The choice between machine learning and deep learning is crucial and should be based on the specific problem at hand. If the task involves structured data and simpler patterns, machine learning may suffice. However, for complex tasks requiring the analysis of unstructured data, such as images or text, deep learning is often the more effective approach. Understanding these use cases helps in making informed decisions. What's next for AI? From models that protect your privacy to systems that understand context like humans do, the evolution of machine learning and deep learning is accelerating and raising important questions about ethics and regulation. The future of deep learning and machine learning is brimming with exciting advancements and emerging technologies. Innovations like federated learning, which allows models to be trained across decentralized devices while preserving data privacy, are gaining traction. Additionally, advancements in natural language processing are making AI systems more conversational and context-aware. However, as these technologies evolve, the importance of AI ethics and regulations cannot be overlooked. Ensuring responsible AI development will be crucial to address concerns around bias, transparency, and accountability. As we move forward, staying informed about ongoing developments in AI will be essential for both professionals and enthusiasts alike. Engaging with the latest research, attending conferences, and following industry news can help you understand how these trends will shape our world. By keeping an eye on these future trends, you can better prepare for the transformative impact of AI on various sectors and society as a whole. The line between science fiction and reality is blurring. Machine learning handles today's problems, while deep learning builds tomorrow's solutions. Understanding both isn't just tech knowledge, it's future-proofing yourself. In this video, we explored the fascinating differences and applications of deep learning and machine learning. We highlighted how machine learning serves as the foundation for deep learning, with simpler algorithms suited for structured data, while deep learning utilizes complex neural networks to tackle unstructured data. We also discussed real-world applications, from finance and healthcare to autonomous vehicles and robotics. As we wrap up, remember that understanding these technologies is crucial for navigating the future of AI. If you found this video informative, please subscribe to our channel and give it a thumbs up. Your support helps us create more engaging content. Don't forget to share this video with friends and colleagues who might be interested, and explore our channel for related topics that dive deeper into the world of artificial intelligence. Thank you for watching, and stay curious about the evolving landscape of AI.